Hello guys, I'm SharathKumar. Now I'm going to explain the hot carrier effects of MOSFETs. Yeah, in this module, let us see the introduction to hot carrier effect in MOSFETs and the causes of hot carrier effects, effects of hot carrier effects, and how to prevent those hot carrier effects, and conclusion and my references. Introduction. Yeah, let us discuss about what is hot carrier effect. The metal oxide semiconductor transistor is accelerated to high energies by the electric field in the channel. The holes and the electrons are accelerated to high energy, which means the power and the force gets higher due to the electric field because of those oxide capacitance. This causes increase in the current flowing through the channel. This effect, we call this effect as a hot carrier effect. This is one of the major short channel effects that we can see in the MOSFETs. Causes of hot carrier effect. Yeah, as I had already said that hot carrier effect is caused by the electric field in channel of the MOSFET. This electric field accelerates Holzer energies high enough to cause impact ionization. It leads to increase in the current flowing through the channel. Yes, as it accelerates the holes and electrons, it automatically leads to increase the current flowing. As a, it's the byproduct. What is the byproduct of current increase of current flowing? We know that heat dissipation will get increased and power dissipation will get increased. Yeah, now let us clearly see those effects in effects of hot carrier effect. The current flowing, when the current flowing get increased in the MOSFET, then what will happen? Then it will definitely increases the power dissipation and current dissipation. And when heat increases, the flow of the electrons in a circuit or the switch will decreases. So the device switching speed will also reduced, and gate oxide degradation. Yeah, to prevent that, we could use the increased thickness of the gate oxide metal. We will see in the next slide. Yeah, it will degrade the gate oxide, and it will reduce the device switching speed. And as we have already said that the power dissipation and the device degradation will occur when the hot carrier effect happens. Preventing hot carrier effects. How to prevent those hot carrier effects? There are several ways to prevent those hot carrier effects. This includes thicker gate oxide. Yeah, the gate oxide wafer thickness has to be increased because the increased thickness of the gate oxide will results in creating more distance between the source and drain terminals. This will reduce the capacitance and overall oxide capacitance of this MOSFET. So this will also reduce the doping concentrations. Use of device design techniques such as source or drain engineering. Use of Schottky diodes. Yeah, the Schottky diodes are nothing but a diode which can also works in reverse bias. We all know that the PN junction carried current only through the forward bias. The Schottky is just more or less like a switch, so we can use that to prevent. Hereby we can conclude that it is a phenomenon that can increase the current flow in the channel, leading to device degradation, and even in a when in long term when continued for several times, it may lead to the device failure too. By increasing the size of gate oxide and by reducing the doping concentration, we could reduce the hot carrier effect. Yeah, thank you so much.